Hi, Mr. Gray. This is my extra credit or makeup credit video. The first subject I'm doing is displacement, and it's like the change in position as seen over there. I'll explain that. And the equation's delta x equals final position minus initial position, also seen written out right there. And the example I wrote is Tim's house is the starter point, and he's going over to Jane's house, and he can take any route he wants, but the total displacement will be 10 miles if that's how far away their house is. So it'd be 10 minus 0, and that would equal 10 miles. Okay, so the second subject is velocity, and that, or I'm going to show you the average velocity formula, and it's just the displacement over time, or change of time, and that's it simplified. So if you only have certain parts, that's what you can use to plug it in. And yeah, this is it written out, the time interval and displacement. The example I chose or wrote is on a drive at ground level or on ground level, Tim covers 1,500 miles in 5 hours while driving east. What is Tim's average velocity? And so the delta x is your 1,500 miles east, and your delta t is 5 hours, and 1 mile is equivalent to 1,609.334 meters, and 5 hours is equivalent to 1,800 seconds. And so you'd plug it in, and you'd get 300 miles per hour due east, and yes, that's very fast, so it's open road, I guess, I don't know. And then, or it'll be 2,414,001 meter over 1,800 seconds, and that equals 1,341.11 meters per second due east. So that's how you do average velocity. Okay, so the third topic I'm going to be talking about is acceleration, and it's delta v over delta t, and it's the change of velocity over change of time. And you'll have the final velocity minus initial velocity over the final time minus initial time. And that's how you find your average acceleration. And so the problem I wrote out is a motorcycle comes to a stop, and it slows from 8 meters per second to 0 meters per second in 3 seconds. And you have to find the average acceleration, so that's what you're looking for. And so it would be 8 minus 0 for velocity, so it would be negative 8 meters per second over time, which is 3 seconds, and that would equal negative 2.67 meters per second squared, because you already have meters per second divided by seconds, so that's how you get seconds squared. Okay, so my fourth topic is vectors, or vector I wrote, and we'll be using SOHCAHTOA, SOHCAHTOA in these examples, but for my example I wrote, we're not going to use tangent at all. Okay, so as a kid is playing with a remote control airplane, and it launches at 25 degrees, traveling at 85 kilometers per hour, and you're going to try to find the component velocities, which is right here and here.